Hello students, now we will discuss laws of thermodynamics. Laws of thermodynamics. First definition is thermal equilibrium. The two objects are said to be in thermal equilibrium if there is no net exchange of heat between them. The temperature of the objects in thermal equilibrium are same. That is, if two objects are in thermal equilibrium, then their temperature must be same. Now, zeroth law of thermodynamics. Suppose two systems which are thermally isolated from each other, system A and system B, but they are in contact with the third system C, that is, they can exchange heat with the system C. Now, zeroth law, it states that if two thermally isolated systems are in thermal equilibrium with the third system, then they are in the thermal equilibrium each other. Consider two systems A and B are thermally isolated from each other and in contact with the third system C. Let TA, TB and TC be the temperature of the system A, system B and system C respectively, because the system in thermal equilibrium have the same temperature. Therefore, if the system A and system B are in thermal equilibrium with the system C, then TA is equal to TC. Let it be equation number 1. And TB is equal to TC. Let it be equation number 2. Now from equation 1 and equation 2, TA is equal to TB, that is, the system A and system B are in thermal equilibrium. Hence the zeroth law of thermodynamics. So this is the zeroth law of thermodynamics, which is the statement of zeroth law of thermodynamics. Now first law of thermodynamics, it states that whenever heat is supplied to a system, a part of it goes to change the internal energy and the remaining is used in doing external work. Mathematically, delta Q is equal to delta U plus W. Let it be equation number 1, where delta Q is heat supplied, delta U the change in internal energy, and W is equal to external work done. Now sign convention for first law of thermodynamics. Number 1, delta Q, the heat exchange is positive when heat is added to the system and negative when heat is given out by the system. Number 2, work W is positive when work is done by the system and negative when work is done on the system. Now number 3, delta U is positive for increase in internal energy and negative for decrease in internal energy. So these are the sign of convention for first law of thermodynamics. Now for isothermal process, first case for isothermal process. In case of isothermal process, temperature of the system remains same. Therefore, the internal energy of the system remains same, that is delta U is equal to 0, means there is no change in internal energy. Hence, according to first law of thermodynamics, delta Q is equal to delta U plus W, but delta U is equal to 0 Therefore, delta Q is equal to 0 plus W, or delta Q is equal to W. Let it be equation number 2, that is, heat energy given to the system is equal to work done by the system in case of isothermal process. Now number 2, for adiabatic process, in case of adiabatic process, heat given to the system is 0. There is no exchange of heat between the system and surrounding. Therefore, Q is equal to 0. Hence, according to first law of thermodynamics, delta Q is equal to delta U plus W, or 0 is equal to delta U plus W, or W is equal to minus delta U. Let it be equation number 3, that is, if work is done by the system, that is W is positive, then its internal energy decreases, that is delta U will be negative. And if work is done on the system, that is W is negative, then its internal energy is positive, that is internal energy increases. So this is the for adiabatic process first law of thermodynamics. Now third case, for isochoric process. In case of isochoric process, volume of the system remains same. Therefore, the work done is 0, that is W is equal to 0 for isochoric process. Hence, according to first law of thermodynamics, delta Q is equal to delta U plus W, or delta Q is equal to delta U plus 0, or delta Q is equal to delta U. Let it be equation number 4, that is, heat energy given to the system is equal to increase in internal energy of the system and vice versa. So this is the case of for isochoric process, the first law of thermodynamics. Thank you very much.